Hey guys, we went through a section where we talked about identities and simplifying identities, and now we're going to take it a step further. We are going to use identities to verify that one expression equals another expression, and this won't be just for one angle or one angle value, but this is going to be for an infinite amount of angles. So to start and to give you an idea of what I mean, we are going to practice with one expression. So we're going to practice with this expression that the secant of theta minus the cosine of theta is equal to the sine of theta times the tangent of theta. We are going to show that both sides of this equation is equal, and we're going to use the value theta equals pi over 6. So we're going to look at this one angle value, and we're going to see if both sides are equal. And the most logical thing to do is to sub in for theta, pi over 6. If both sides equal out, then we know that this is true. So let's go ahead and work out this problem. I am encouraging you to pause the video. You are going to substitute in pi over 6 for every theta value. So you'll have secant of pi over 6 minus cosine of pi over 6 equals the sine of pi over 6 times the tangent of pi over 6. And I want to see if you can work that out. All right, let's see what you get when you work this out. So the first thing that we need to do is we need to remember that pi over 6 coordinate points on the unit circle. So if I think about where pi over 6 is on the unit circle, on the unit circle, there's pi over 6, right? I know that terminal point right there is radical 3 over 2 and 1/2. So if I talk about the secant of pi over 6, I know that I'm just going to flip its cosine value. So I know the cosine's radical 3 over 2. So the secant of pi over 6 is 2 over radical 3. Minus the cosine of pi over 6, we already just said that's going to be the x value. That's the cosine, so it's radical 3 over 2. And then it's going to be equal to the sine of pi over 6, which we know is 1/2, times the tangent of pi over 6, which the tangent of pi over 6 is the sine divided by the cosine. So we're taking 1/2. We're going to be dividing it by radical 3 over 2, which is the same as saying 1/2 times 2 over radical 3. So we know the tangent, when those 2's cancel, is going to be 1 over radical 3, right? So we got 1 over radical 3 as my tangent that I'm substituting in. So let's look at the left side. If we add these two together, remember we need a common denominator. So that means our common denominator, what I'm looking at here, is going to be a 2 times a radical 3. So we're going to have 2 times radical 3 in the denominator, which means for this first fraction, I got to multiply this first fraction, both top and bottom, by radical 3. I'm sorry, not radical 3, 2. I got to multiply it by 2, top and bottom. And then the second fraction, I have to multiply it by radical 3, top and bottom, because it's missing the radical 3, right? So in our numerator, we should have a 2 times 2, which is 4, minus a radical 3 times radical 3, which is just radical 9, which is 3. So we got a 4 minus 3. 4 minus 3 is 1. So I'm going to rewrite this down here as 1 over 2 radical 3. All right, over here, let's see. I end up with a 1 times 1, which, and let's just move it down here. It's going to be 1. And 2 times radical 3 is 2 radical 3. And notice the left side does indeed equal the right side. So we can say this is verified. So we have verified that the secant of theta minus the cosine of theta is equal to the sine of theta times tangent of theta. But we've only verified that for the angle value pi over 6. As we move through verifying identities, what we're going to do is we are going to verify identities for every single angle. And in order to do that, we're going to verify expressions for every single angle. And in order to do that, we have to use our trig identities. So you're going to be using those trig identities to verify expressions and verify that they work for every single angle. And so let's try that on the next slide.